and today is 4/10/15. There will never again will that sequence of numbers exist on a date in in exactly that format. Well, not for 100 years. If we write it out in full, never again. It's amazing. Okay. Enough of my... Okay, so we've got a deep sea research station, and these actually do exist. And it's in essence a contained environment 200 meters below the surface of the ocean. So it's in the Pacific, highly pressurized environment, obviously. How many liters of gas at STP must be compressed on the surface to fill the underwater environment with 2 times 10 to the 7th liters of gas at 20 atm? And we're assuming temperature remains constant. So this is really a simple problem. It's just a V1, P1, V2, P2, because temperature is a constant. But all the detail always throws people off. Maybe I have one that I've used with all 3 variables. I forget. So anyway, we're told, we're given the initial temperature and pressure of the gas. How many liters at STP? So we have our pressure. It's 760 torr. Oh, they're using ATMs. So actually, let's scratch that. 1.0 ATMs. And remember, when we're given STP, we kind of assume infinite sig figs. We assume that when it says 1 ATM or single atmosphere or standard pressure, we're assuming that's infinite sig figs. They don't count against us. Volume 1 is what we're looking for. And pressure 2, we're told, is 20 ATMs. Volume 2 is just the capacity of the station. So 2.00 times 10 to the 7th liters. This one's too easy. Jeez Louise. I can't believe I ever assigned that. Okay, so V1 equals V2 P2 over P1. And it's just plugging in. Okay, so we get 4.0 times 10 to the 8th liters of gas that has to be compressed at surface level. And how many sig figs do we actually get? 2? 3. We get 3, so it'd be 4.00 times 10 to the 8th liters. Okay, that one was way too easy. That's not the one I was thinking of. Let's do one that's a little bit more difficult, with some dry gas, perhaps. Okay, let's look at number 46 in the mixed review together. Okay, never mind. That's just straight up combined gas law also. I thought it was subtracting out pressure. I'll tell you what, I'll make one up that way because I think some of you have wanted more practice on those. Is that true? Okay, so let's do one together and then I'll just give you time to work on your own. Okay, so we have a problem here. We have a 125 milliliter sample of nitrogen collected at 32 degrees Celsius. The barometer in the lab reads 756 on the day of collection. What is the volume of the dry gas at STP? So we've got our initial conditions given in the problem. The volume is 125 milliliters. And the initial temperature is 32 Celsius, which is 305 Kelvin. So we just need to figure out the initial pressure. We have to take the total pressure minus the pressure of the water vapor that's mixed in with that to get the pressure of our nitrogen. So we have to go to our lookup table, page 899 in the book. Where does the 756 go? Total pressure. So it's not your pressure 1, it's your total pressure. So 756 torr, and using the chart on your quiz, partial vapor pressure of water at 32 is 35.7 torr, and now we have the pressure of our nitrogen. Okay, so what do we get for the pressure of our nitrogen? Okay, so we now have that pressure of nitrogen, that's going to be our P1. So 720.3 torr. Okay, I'm going to get rid of all of this because we've used it, we know what we did with it, now we're just going to get it out of there. For our so we're looking for V2. And our final conditions are all specified in one little 3-letter phrase, STP. So anytime you see STP, that gives you pressure and temperature. What's the standard pressure? 1 atm, or 760 torr, since we're already in torr. What's standard temperature? 0 Celsius, 273 Kelvin. Okay, and that leaves us with everything we need. So now we just need to write down our formula. So V1 P1 over T1 equals V2 P2 or P2 V2 over T2. Let's do some rearranging to solve for V2. Okay, so we have our rearrangement, and now we're going to plug in. We have everything plugged in, and now it's just a matter of computing. So we get a raw answer for volume of 106.040714 milliliters. How many sig figs do we get? 2. So this would be 110 milliliters for our final volume. So it's shrunk somewhat. It has shrunk somewhat. Okay, questions, comments, or concerns on these kind of problems? Sample problem for you to do on your own. 4.75 liters of CO2 is collected over water at 23 degrees Celsius. Barometer reads 761 torr. What is the volume of dry CO2 at standard pressure and 25 degrees Celsius? So not STP, but standard pressure and 25. Go. Okay, so the raw answer then is, drum roll, V2 equals, and if you haven't done this yet, hit your pause button now. 4.655620777 liters. We have 3 sig figs because we did have a 3-digit temperature, so that would be 4.66 liters. So it's shrunk a little bit. It's compressed a little bit. Okay, that's it. Sorry, yeah, no, it is 2 sig figs. Well, you know what? Because I mean, I'm the goofball who wrote this. This isn't based off real lab measurements. So let me fix that by doing that. So now it's 3 sig figs. So since this is my magical thermometer that I just made up, it could have lots of sig figs that it doesn't have. If you have questions or problems with this, I've got a study hall 7th period. Come see me.